Students, how are you all? I hope everyone is doing well. So from today onwards, we'll be starting with class 12. Okay. So the first chapter is your relation and function. I hope and you all have understood the concepts of class 11. Okay. Why? Because it is very important to understand class 12 chapters. Okay. Because already in class 11, see, the chapters which we have got earlier is just a repetition of it. Okay. But with some higher degrees and higher standards. Okay. So, today we'll be doing this relation and function. Now see, in class 11, you all have studied about Cartesian product, then what is relation and what is function, right? These three things we have learned. But in class 12, in this chapter, we'll be dealing with the types of relations, the types of functions and all this. Okay? So basically, the concepts which you have studied earlier in class 11, it will again be used here in class 12. Okay? So today, since this is the first class, so I will be just dealing with whatever you have learned and I will take it towards class 12 because those basic concepts are very important to understand what we will learn here in 12. Okay? So therefore, today I will simply start with the basics, that is the Cartesian product, relation, function. Okay? And gradually we will move towards the types of relations, types of functions and all this. Okay? So let's start today's class. Now see, in class 11, you all have learnt about Cartesian product, right? Cartesian product. So, what is Cartesian product? What is Cartesian product? Cartesian product means the product of two sets. So again, in class 11, you have learned about sets. So what is set? A set is a set contains all the elements, right? So basically, if I say that there is a family, so that family is a set and within that family there are members, right? So those members are the elements of the set. So Cartesian product means the product of two sets, right? The product of two sets. This one is the set A, this one is the set B. So their product will be the Cartesian product. Okay? So this is Cartesian product. Say, for example, so what I have said? I have said that it is the product of two sets. Okay? It is the product of two sets. Now say for example, given that there are two non-empty sets. Okay? Say for example, given P and Q are two non-empty sets. Two non-empty sets. Okay? Non-empty means they have some elements. Okay? Now, the Cartesian product, that means P into Q, right? This is the Cartesian product. Is the set of all ordered pairs whose first component is a member of P and the second component is a member of Q. Right? That means the Cartesian product means the set of all ordered pairs. This is very, very important. The ordered pairs. Okay. Whose first component is a member of P and the second component is a member of Q. That means that Cartesian product should be the set of all ordered pairs. Okay. So, also we have learned that two ordered pairs are equal if and only if what we have learned? We have learned that two ordered pairs are equal if and only if the corresponding first elements are equal and the corresponding second elements are also equal. Right? This is what we have learned in the ordered pairs. Those ordered pairs, what we have got in the Cartesian product, are equal if and only if the corresponding first elements are equal and the corresponding second elements are also equal. That means, how we can show? That means A comma B is equals to B comma A. Right? Right? We can say that the ordered pairs are equal. Okay? If that is A comma B is equals to B comma A. But say for example, we have A, the set A and the set B, their Cartesian product. Is it equal to the set B into A? Can we say this, that A, the set A and the set B, their Cartesian product is equals to the Cartesian product of set B and set A? Can we say that they are equal? No, they are not equal. Why? Let's take one example. Now see, say for example A is equals to, we have A comma B. Okay, we have A comma B. Then B is equals to, say for example we have 5 comma 6. Okay, now what is Cartesian product of A and B? It will be A comma 5, right? Then A comma 6, then we have B comma 5 and we have B comma 6, right? Again, what is the Cartesian product of B cross A? So B into A, it will be 5 comma A, then we have 5 comma B, then we have 6 comma A and we have 6 comma B, right? So, are they equal? No, they are not equal. Okay, so this is how we can show that the Cartesian product of two elements is not equal to Cartesian product of the, if we reverse it. Okay, so this is what we have learned, right, about Cartesian product. That means Cartesian product is the product of two sets and it must be ordered pair, right? That must be ordered in ordered pair. Okay, if the first component is a member of P and the second component is a member of P. Okay, so this is the basic concept regarding the Cartesian product. Right. Next, we have learned about relation. Now, what is a relation? See, already I have mentioned that within a family, right, within a family, that is within a set, there are elements, that is there are family members. And within those family members, there are some kinds of relation, right? Parents relation, siblings relation, right? Grandparent relation. So those are some kinds of relation. And for a relation, always two are involved. Okay? So there should be two identities, right? Between two identities, you can show a relation always. Okay? Now, if I take mathematical examples, okay, if I take mathematical examples, say for example, you have already learned about coordinate geometry, right? X and Y axis, right? So these two are in a relationship. Okay? Parallel lines. This is parallel to this, right? You can show relations like this. Okay? Or else you can, in sets also, you have learned that the set A is a subset of B. That means the elements of A are also the elements of B. So that's why it has become a subset. So subset is a kind of relation. Okay? So these are relations. Now, relation, what we have understood, relation means connection, right? It is a form of connection, and connection always involves two identities. So it involves two identities. Okay? Now see, so everyone is in a relation with each other, right? Now see here, these relations are they same or are they unique? Everyone is unique, right? They are not same. This is perpendicular, this is parallel, this is subset. So all the relations are unique, right? So therefore, we can say that every relation has a pattern, or they have unique properties. Okay, we can say like this. They have unique properties, right? So relation means it involves two identities, and every relation has a specific pattern. Okay, now how will we define relation? So a relation can be defined as a relation R from set A to set B is a subset of the Cartesian product A cross B, right? That means the relationship from set A to set B is the subset. This is very, very important. Is the subset of whom? Subset of the Cartesian product, right? Subset of the Cartesian product. Okay, so the subset is derived by describing a relationship between the elements of A cross B. That means if we need to define the subset, then how will we describe? We will derive it from the Cartesian product. Okay, this is how we can show the relationship. Understood? So in relationship, you have learned about three important things. Okay, you have learned about three important things. So what are they? First of all, you have learned about domain. Then you have learned about range, and then you have learned about codomain. Right? So these three things you have learned in a relationship. Right? So what is domain? Domain means the set of all permissible inputs. Okay, set of all permissible inputs. What inputs we are giving, right? Range means the set of all permissible outputs. That means what inputs we are giving and what outputs we are gaining. Okay. Codomain means all the possible outputs. That means whatever outputs it may have, all the outputs, it becomes the codomain. But range means only the inputs what we are giving and what outputs we are giving. This is the range. But codomain means all the possible outputs. Okay. Now, say for example, we have 1, 2, 3, 4. Okay, 1, 2, 3, and we have, say for example, Anil, Ravi, Hari, and okay. Now see here. If I say that this relationship what? The function of set A to set B. The relationship from set A to set B. Not function, sorry. The relationship from set A to set B is the subset of the Cartesian product. So what will be the Cartesian product? So how many elements will be in the Cartesian product? So A cross B. How many elements? So here we have 4. Here we have 4. Right? So how many elements we will get in total? We will get 12 elements. Right? Sorry, if we take here only, let's take 3. Okay. So we will get 1, 2, 3 and 1, 2, 3, 4. So how many elements in the Cartesian product we will get? We will get 12 elements. Right? We will get 12 elements. Okay. Now, what is the domain? Domain means the input. What criteria we are using. Say for example, we are only using 1 and 2. Okay. That means the criteria, suppose the criteria is 1, 2. Okay. Now, what will be the relation? The relation will be 1 and Anil, 1 and Ravi, 1 and Hari, 1 and Deepak. Right? First relation. Second set of relation will be 2 and Anil, 2 and Ravi, 2 and Hari, and 2 and Deepak. Right? Right? So that means we have built a relation with whom? With only these three members. Okay? That means here, what is the permissible inputs? The permissible input is only 1 and 2. Okay? If we have taken 1 and 2, so what are the permissible outputs? So the permissible outputs will be, we have taken this one, this one, this one, and this one, right? We have taken 4 of them. So it will be, here we have 1, 2, and 3. And here we have Anil, Ravi, Hari, and okay. Now there are 3 important things which you have learned regarding relation. Okay. The first one is the domain. Okay, you have learned about domain. Then we have learned about range, right? Then we have learned about co-domain. So these are the 3 important things which you have learned regarding relation. So what is domain? Domain means the set of all permissible, that is, what is permitted, permissible inputs, right? So whatever inputs we are providing. Okay. Range means the set of all permissible outputs. That means what is only permitted, right? Permissible outputs. Next, we have codomain. Codomain means the set of all possible outputs. All possible outputs. That means, what is the difference between this range and codomain? Range means only the permissible outputs. Okay, what is permitted. But in the codomain, you will have the all possible list of outputs. Okay, this is the difference. So let's take one example. Okay, let's take one example. Say we have to define a relation A to, have to, given that A is equals to 1, 2, 3, 4 up to 14. Okay, then we have to define a relation. Define a relation A to A. Okay, we have to define the relation A to A, and the given condition is such that the given condition is the relationship is defined as x comma y. X comma y means the elements of A, right? Such that 3x minus y is equals to 0, where x comma y belongs to A. Okay, this is the given condition, right? Now see here. Now see here. Since the given condition is thrice x minus y is equals to 0, it is the given condition. So which implies y is equals to thrice of x, right? So what we have got? Y is equals to thrice x. Now here r is equals to x comma y, right? And x, y means thrice of x. Okay. So now, if I take, let me write this part in the next slide. Okay. The given condition is r is equals to x comma y. So what is y here? It is thrice x, right? Now see, if I take x as 1, Okay, if I take x as 1, then what will be times x? That is y, it will be 3, right? If I take x as 2, then what will be y? It will be 3 into 2, that is 6, right? Next, if we take 3, then 3 3 is 9. Next, if we take 4, then we will get 12. Okay? Now see here. Now see here. We have to find the relationship between domain, range and codomain. Okay? So, since we have established a relationship, that is 1 3, 2 6, 3 9, 4 12. Now if I show it like this is A to A to A. Okay. Here we have 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Okay. Here also we have 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. Okay. Now see here. We have to show the relationship that taken 5 here, then 5 3 is 15. Does the set A has 15? No, it has only elements till 14. So that's why we cannot take 5. Understood? Now see here. Now the important point is, what will be the domain here? What will be the domain? So domain means the set of permissible inputs, that is what is only permitted. 1, 2, 3 and 4. Is 5 permitted? No, 5 is not permitted. If 5 would have been permitted, then there should be 15 also here. But there is no 15. So that's why the permissible inputs is only 1, 2, 3 and 4. So that means the domain is 1, 2, 3, 4. Right? Next, we have the range. So what is range? Range means the permissible outputs. What are the outputs that are permitted? Okay, there are so many outputs, right? Out of this, 3, 6, 9 and 12 is only permitted. Okay, so that means the range is 3, 6, 9 and 12. Okay, now see what I have written for codomain. Codomain means all the possible outputs. All the possible outputs. That means, what are the possible outputs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 up to 14. So, range and codomain. So, codomain means the all the possible outputs. That is 1, 2, 3 up to 14. Okay. Now understood? This is the concept regarding the relation. This is what relation is all about. That means we have to show a relationship between the two sets, which is a subset of the Cartesian product. Okay. Now relation. Okay, the number of relation. Number of relations. So what is number of relation? It is the number of possible subsets of A cross B. Right? The number of how many possible subsets are there in the Cartesian product. Okay? And if number of elements in the set A is equals to P and the number of elements in the set B is equals to Q, then we can say that number of elements in the Cartesian product, that is A cross B is equals to P into Q. Okay, this is what we can say. Thus, the total number of relation or subset is always 2 to the power P. Okay, it's always 2 to the power P Q, which is very, very important. So let's take one example. So see, let's take one example. Say for example, A is equals to 1, 2. Okay, and B is equals to say 3. Okay, now how many elements in the set A? There are 2 elements. How many elements in the set B? There are 3 elements. Okay, sorry, there are 1 element. Okay, now how many elements in the Cartesian product, that is A cross B? That is 2 into 1, which is equals to 2, right? So what is the relation? Number of relation. Therefore, number of relation or subset. How many subsets will be there? There will be 2 to the power PQ, that is 2 to the power 2, which is equals to 4, right? So how will we get? Now see, A cross B means what? 1, 3 and 2, 3, right? So what are the subsets of A cross B? What will be the subsets? So the subsets will be, first of all, we have phi. We have already learned in the vector sets that phi is the element of every set, right? Then we have 1, 3, right? We have 1, 3 alone. Then we have 2, 3 alone, 2, 3. Then we have at the last 1, 3 and 2, 3, right? So how many are 2, 3 and 4? So that means we have 4 number of subsets or groups. This you have learned in class 11. And this is how we will continue. Now, we have learned about relation. Now see, when I have said that we all are in a family, okay, we all are in a family and everyone has relationship with one another. Now, at home, when there is a relation, obviously you all have different kinds of functions, right? So your duty is to study, your parents' duty is to earn, to do the household work and all, right? So everyone has the individual duties. So those duties are basically the functions. Okay, so everyone has different kinds of functions. So now, if I have to define function, then this is nothing but set of actions, right? It is set of actions or activity. What activities you are doing, right? So basically, if we give some input, say for example, there is one machine, say for example the fan, okay, we are giving input, that means we are switching on the switch, right? Then this is the fan, it will do the work, that is, it will rotate. Since we are providing electricity, it will rotate, right? And that means here some functions are going on. Okay, it will do some function. And we will gain some output. That means when you switch on the fan will rotate. And what we will get? We will get cool air, right? That means the cool air is the output. Okay, so definitely there is a relationship between the two, right? Now, so the machine is, say for example, f of x is equals to, we always denote it like this, right? twice x. And we have the elements 2, 4, 8, 10. Okay. Then obviously we will get some output, right? If we use this function twice x, we will get some, definitely we will get some output. So what will be the outputs? So twice x, that means 2 into 2, it will be 4. 4 into 2, it will be 8. 8 into 2, it will be 16. 10 into 2, it will be 20. So that means using the functions on the inputs, we are getting some outputs. Okay, so that means functions are defining a kind of relation. All functions are relation, right? So all the functions are the relations. Okay, and can we say that all relations, can we say that all relations are functions? No, all relations are not functions, because some relations don't define any function between them. Okay, all relations are not functions. Okay, that means if all relations are not functions, that means some of the relations are only functions. So some relations are only functions, right? So this is all what we have the of class 11, and this we will relate with it class 12 relational. Okay, so in the next class we will be learning about the types of relations. Okay.